Good day, everybody. Today we are going to talk about electronic structure of atom. So I'll share my screen with you. Okay. So let's put it on slideshow. Notes on electronic structure of atom. The periodic table. The periodic table shows the atomic number with the element symbol. The atomic number indicates the number of electrons in the atoms of an element. Electron configurations of elements help to explain the importance of physical and chemical properties. The importance and usefulness of the periodic table lie in the fact that we can use our understanding of the general properties and trends with a group, which is a column, or a period, which is a row, to predict with considerable accuracy the properties of an element, even though that element may be unfamiliar to us. Next, we are going to talk about chemical bonding. Chemical bonding allows for the fundamental connection or attachment of different and unique elements to form through complex chemical interaction. So it should be through. Chemical bonding represents the use of chemical mechanisms to further allow bonding to occur between certain elements or compounds that we know to exist. A common example of chemical bonding or bonding in general is rubbing a balloon on the carpet and then holding it up to someone's hair and seeing the hair becomes attracted to the balloon. At the atomic level, atoms are composed of particles that have charge, positive, negative, or neutral. Further, static electricity is the result of an imbalance between negative and positive charges in an object. The rubbing of objects against one another almost always causes a transfer of electrons or protons, which further implicates a transfer of charge. When we rub a balloon on the carpet, negative electrons will build up on the balloons. Thus, there is attraction between air and the balloon as they hold different charges that attract. It is important to recall that in this case, appropriate opposite charges attract one another. Thus, the explanation sums up at the atomic level why things may attract. What is a covalent bond? A covalent bond is a bond in which the electrons are shared by two atoms, such as in a molecule of hydrogen, H2, where each H atom shares each other's electrons. The shared pair of electrons, not PF, of electrons is often represented by a single line. Thus, the covalent bond in hydrogen molecule can be written as H, then that bond, which is a horizontal line, H. In a covalent bond, each electron in a shared pair is attracted to the nuclei of both atoms. Okay. So what is a nuclear charge? Nuclear charge is the ability of protons in the nucleus of an atom to attract the electrons outside the nucleus. Next, we're going to talk about wave. A wave can be thought of as a vibrating disturbance by which energy is transformed. The fundamental properties of a wave can be studied by observing the propagation of ocean waves on a sea beach. The regular variation of peaks and troughs enable us to sense the propagation of the waves. Now, Louis de Broglie in 1925 first proposed the wave nature of atomic constituents. So next, we are going to briefly discuss about quantum mechanics. Quantum mechanics deals with atomic bonding because it discusses about the technical processes of atoms. For example, the quantum mechanical model tells us that any two electrons occupying the same orbit must have opposite spins. That means they spin in opposite direction, opposite to each other. This is an essential foundation when talking about atoms, because when atoms bond, we must know what is happening within the atom that allows them to bond. For example, magnetism happens because of spin of an electron. Quantum mechanics continued. Quantum mechanics proposes that we cannot pinpoint an electron in an atom. However, quantum mechanics defines the region where the electron might be at a given time. A concept inherent to quantum mechanics is electron density, which gives the probability that an electron will be found in a particular region of an atom. Next, we're going to talk about metal. A metal atom in a crystal form can be thought of as an array of positive ions immersed in a sea of delocalized valence electrons. The great cohesive force resulting from delocalization is responsible for a metal's strength. That is, these positive ions are attracted to the delocalized valence electrons and they strongly attract each other, and hence there is a huge cohesive force. Cohesive means bring them together. The mobility of the delocalized electrons makes metals good conductors of heat and electricity. So it is the delocalized valence electron that help the metal to become good conductors of heat and electricity. Metals also lose their own electrons easily to form a positively charged ion called cations. An example of that will be sodium metal. Sodium is a metal. It loses electron to form a Na plus ion, which in combination with a chloride ion, which is a negatively charged ion, attract each other. Sodium plus and chlorine negative, chloride negative. They attract each other and form the salt, NaCl, crystals of salts. Table salt I'm talking about. So I will stop here today. If you have any question or comment, do not hesitate to write me a comment. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. If you like this video, share with your friends. You and your friends, please become a subscriber of my channel by hitting the red subscribe button at the bottom right corner. I'll be back next time with another chemistry presentation, or I solve all kinds of math problems in my channel. So do not forget, please do not forget to come back next time to check out the math problem or the chemistry presentation that I will do. Thanks for watching. Take care. Have a nice day. See you next time.